calculating squares and square roots of non-perfect squares, we can use calculators, or we'd be asking you to estimate it. For these ones here, we can just put into our calculator. So if you want to square 1.2, we do 1.2 squared. And it's important to recognize that squaring is not exactly the same as multiplication, although we do get the same result if we do 1.2 times 1.2. The math behind multiplication and the math behind powers is different, so we don't want to confuse the two. If we have square root 665, we just put that in our calculator. We know it's got to be bigger than 25 because 25 squared is 625, and we know it's got to be less than 26 squared, which is 676 if I'm not mistaken. So from our calculator we get 25.787, so I'm going to round that to 79. To find the area, squaring is a little bit different than multiplication. That squaring takes an area or side length and gives us a square area, whereas multiplication, we multiply length times width, we get the area of a rectangle. Now what's different is specifically squaring, there's only one input and we get a square, specifically a square area. So we're going to square this. So 3.4 squared is going to give us 11.56. When we start with an area, we can square root, and square root is different than dividing. We are having only one number here, and we're going to find the side length by square rooting. So that's what square rooting is. We go from square area, so there's 22 squares, and we get a side length of 4.69 approximately units. Okay, so if I reverse that and multiply 4.69 times 4.69, I would get this area of about 22 units squared. In combining like terms, we have to first of all recognize when we have like terms. This 3 counts x's, this 13 is counting ones, so we can only count x's with x's, ones with ones. When we have zero pairs, so if I have a minus 2x and a plus 2x, they cancel out. It's important to recognize that the sign in front of the number indicates what we're doing. Okay, this is a plus 13, this minus goes with the 2x. So these cancel out, so I end up with a total of 3 x's, 13 ones, take away, remember that's a minus 5, take away 5 is going to be positive 8. When we have x squareds can all go together. So I'm just going to group those like this. Again, the sign that goes in front goes with the term. The x's and x squareds are different, so we do not count x's with x squareds. We count those separately. So I'm going to count up my x squareds first. So I have minus 3 plus 6 plus 1. So that's going to give me plus 4x squareds. I have minus 4 minus 1, so I have a total of minus 5 x's. And then we can count all the ones, plus 9 plus 7, and we count all the ones together and we get 16. And we cannot combine anything else. We cannot put any of these coefficients together because 4 is counting something different than the 5 here and the 16 here. When we have terms inside brackets which we cannot combine together, we can get around the bedmass. So usually we do brackets first. So we can get around the bedmass by doing something called distribution, which means that if I have a multiplication, I can distribute it across plus and minus. I cannot distribute across times, so there's a times in here. I can't distribute across that, but I can distribute multiplication across addition, subtraction. So I end up with 2a squared minus numbers times numbers, letters times letters. Okay, so that's my answer. I can model this, I can see what this looks like because I have multiplication. We show multiplication with length times, the bracket would then be the width, and the resulting area, a times 2a, and 2b times 2a is negative 4ab. We can see the resulting area is the two area pieces that we get when we distribute. And again, these are not like terms, so these cannot be combined together. When we have expressions that look like this, you have to be very careful because you cannot do 4 minus 2 first, because we have to do the multiplication before the subtraction. That means I have to get rid of these brackets by distribution. Now when we distribute, make sure that you distribute with the negative. That negative is going to affect the signs after that. And when we're doing our work, we always make sure we keep track of everything that we don't use. So that 4 we have to keep the same, so we have to make sure we write the 4 in the next line. We distribute into the brackets, so we end up with negative 6x. And this is where it's important. The negative is a positive. So we're going to subtract a negative 4. We're going to actually add 8. Make sure you bring down the 2x. Now we can combine like terms. This is a positive 4. Remember, this negative only goes with the 6x. So positive 4, positive 8 is 12. Negative 6x's. Again, maybe I'll just show that I'm including that negative as when I'm counting that. Negative 6x's plus 2 is going to give me negative 4x's. So there's my final answer.